Good morning. Today we're going to be looking at how we can use the Java data structure and array and how it actually works inside some information components. So we'll look at that. The first thing we're going to take a look at before we actually talk about the arrays themselves is some vocabulary to go along with that. We have our square brackets, aka the actual keyword, quote unquote, for the Java array. And this is the way we can actually look inside the array. It's how we access its component pieces. We have the idea of an index, aka the variable we put inside those square brackets, either a variable or a value, and that has to be where you are inside the array, and it has a range value from 0 up to and including arrayname.length minus 1. We have a single data member that belongs to our array class, and that's the .length, and that tells us how many slots are inside the array. So if I have an array of size 5, I have slots 0, 1, 2, 3, and 4, but not 5, because again, it's up to 0 to length minus 1. And finally, we have a variable index out of bounds exception. This is the error that we throw if I somehow manage to go outside of the bounds of my array, aka a negative value, index is less than 0, or that if I go greater or equal to arrayname.length, because again, if I have a 5 spot, the last spot in there is spot 4. So we want to make sure we keep that in mind when we're talking about the vocabulary that goes along with that. We don't want to throw an index out of bounds exception. Now we have the actual definition in code of an array right here. And so if we take a look at this first thing, we have a capital T slash lowercase t type, aka what's inside the array. And so that's what's going inside it. We then have the actual type itself. The array is of type array. So it's a type thing. So it's a nice compound initialization. So it's, again, one of the many reasons why arrays are hipsters, the way we actually structure inside the code. We then have the name of the array. And again, when we're naming our variables, we want to make sure we give a name that makes sense, that covers the content, so we know what's exactly being stored inside it. Usually a great way to do this, plurals, yes. Because we're assigning something into it, of course, we use the assignment operator, aka the equal sign, and that's where it goes right there. Now, arrays, even though they're weird, they are still an object, so we have the new keyword, we have to initialize memory for them, and so the new keyword is how we handle that. Again, we have the T type, which is what's going to be inside that. And when we look at this right here, we have a nice little matching. The type on this is going to match what's over and left. So you want to make sure that we have those two together, that type that goes along with it. And finally, the last part of when we're putting an array together, we have to identify how big that array is going to be, how many slots are going to go inside that. And so that's how we're going to put the array itself as a structure together every time we use it by default. Now, why is an array so hipster? Now, an array is an object. It's a capital object. It's a thing. It acquires memory. But however, it has no constructors, no methods of its own. There are no use of parens at all. I know. Bizarre. It has a public data member. Now, I know this violates all the things that we've been talking about in class. It's something we would never do, but because array is something that it's a holdover from older code, we have to make sure we have a way of getting access to it, and so it's a little bit special. So it has a public data member. However, this public data member is not modifiable by the user at all. Once I create my array, it's stuck. So that .length, even though it's a data member, it can't be changed. Now, array is the only time in Java we use the square brackets. In other languages, there's a whole bunch of times to use that. But in Java, the only time we use the square brackets is in that hipster of code, the array. Now, I know I said that this is the keyword for it, but guess what? There actually isn't a keyword. The array doesn't have a word for it. These square brackets can be spaced as far apart as they want to on that, and when we're doing multidimensional arrays, we use multiples of these. So it's not really a special thing, but we'll go from that. Another reason that arrays are so hipster is they're fixed in size. They're this big or that big or this big or that big or wherever big you set them at, but they are not resizable. So they don't change at all. So a little bit hipster. An array is a holdover from C/C++, especially though we're actually using it inside of code. But at least in Java, unlike a C or C++ array, we know how big we are because we have a .length. So we are kind of weird, but at least we know how big we are. It's really good. Now, there's 2 extra additions to hipsterness on this. We have our second level hipster. We can have an array with initialization sequence. That's where we have the type, the square brackets, our array name, and then after the equal sign, we do set of squigs, and we have our variables separated by commas. But if we know what's going on and we're going to only use it inside a block of code, aka method, great way to do that. Now, there's on top of that, there's a third level hipster. This is where I know I have to have an array as a data member for my class, but I don't know what I want to put in it at first. So what I'm going to do is I'm going to go ahead and define an array as a value up in my data member section as a private type array. And then in my constructor, I'm going to go ahead and set array is equal to type, square brackets, and then squigs, and then the values I'm separated by commas. But right here, that sequence that we see right here on this can only happen with that sequence right here where it has the type, square brackets, and then this. That's the only time you do it. You can't do this one right here and have it like this where it's going to be defined again afterwards. You have to do it with this if you want to make a new array after you've defined it earlier. So a little bit special. Again, arrays are hipster. We know this. It's okay. We'll use them and do some cool stuff with it later on. Now, arrays, there's a replace, not remove. We don't actually take anything out of an array. Because it's fixed in size, we can't take anything out. Again, I'm using the capital versus lowercase thing where I can talk about the idea of objects versus primitives, and so you can only replace them with a value. And so when you place the array name subindex on the left-hand side, that's how we know that we're actually assigning into the array, aka replacing for it. Now, we want to also make sure that when we're replacing the array, we have a good way of identifying what we're doing with that. One of the ways we can do that is the idea of using, instead of 0 or just simply small negative number, use integer.min value when we're talking about a primitive value, because integer.min value is clearly an explicit identification of something we want to do that's different from what we're doing, because it's actually quite possible we want to store negative numbers in an array. But integer.min value, that's not something we use all the time, so it's clear that, oh, boom, here's a special value. Especially when you're actually storing things that want to be counted or stored or done something for averages. 0 is a big deal. We want to keep that in used. But when we want to say something's explicit, like, oh, this is something we want to watch for, integer.min value, better idea. If we're using an object-based array, then the standard replacement value is going to be null, because we can't simply just put 0 in an array. We have to put an object of that type, because arrays are single-type objects. I can't just throw this, that, and the other in there. I can only throw this kind of thing in there. And so the default on that is going to be throwing a null in there. It's also really easy to check to see if something is already been placed, because by default, when we create an array, it's filled with nulls. So if we check to make sure it's not equal to null, we know we've actually put something inside that, or it's ready to have a new value in there. Great to do, easy to make code work. Okay. Finally, retrieval. The next thing we have is we want to get a value outside of the array. So we place the array name subindex on the right-hand side of the equal sign. So if we're going to use the assignment operator, if it's over here on the right, that means that we know that we're actually taking something out of the array, not actually taking it out, but we're retrieving the value from it and storing it into a variable or using it in something. And so again, we can't actually put anything into a method, so we have to assign it to a variable, of course. But when we're retrieving a primitive, you get a copy of that value. So if I have an array of ints, and I have 1, 500, 243, 16, blah, 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 and I ask index sub 2 for that value, then that value, that 3 that's right there, I get a copy of 3. I get my own special 3 just for me. It's mine. The 3 that's inside the array, it's okay. Won't hurt it. I can do anything I want. I can change my 3 to a 504. I can change my 3 to negative 42. It won't hurt it at all, because the 3 that's actually stored in the array, it's right there. It's safe. It's good. However, if I look on the other side, when I'm talking about taking something out of an array that's an object, I want to do that, I actually can impact the state. I can change that object. And so when I use the square bracket retrieval to actually get something out of that array, I can impact the state. So current thing is my array subindex. Current thing that does stuff to state, that example right there, I'm impacting the object that's inside the array. I'm changing it. If I set it's null and I use that square bracket access, I'm actually replacing the value there. So you want to make sure that when you're using retrieval, you realize that there's a difference between an object and a primitive. If you get a primitive, you get a copy. Extra versions, everyone's happy. If you change the actual original object with an object type, then you're actually affecting that state, and you assign into it or change it, you're going to be replacing that object, and that has an impact on the actual code. So keep that in mind when you're actually working with that. Now, when we look inside the array, most of the time we're looking inside the array, we're going to be doing that with a loop, because we have to go over lots of things. It's the whole purpose of having a big giant thing we want to store over and go bop, 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 to actually go through those pieces. And so when we do that, we're going to use a loop to do that most often. The index parameter inside the square brackets has to meet the following conditions. Index has to be greater or equal to 0, and not or, and has to be less than dot length. You can't, so if you have a 0 size array, obviously it has to be less than that, so you can't actually go inside it. So it has to be greater than 0, and if there's nothing in there, you can't have anything in there. No big deal. But you also have to make sure you're not going outside of 5. So if I have 1, 2, 3, 4, 5 things in my list, my last spot is 4. So making sure that I have to be less than length. Now, if we're using a standard for loop for replacement of values, we have to use the square bracket access, because the only way we can replace things is with a standard for loop. A for each loop, aka the enhanced for, is great to go through and print everything out, to look at all the values, to report things off to the screen, do some calculations on, say, for example, everybody's grades. Wonderful. But you cannot, no way at all, change the contents of the object using a for each loop. All it has access to is to call methods on state. So keep that in mind when we're using a for each. We can't replace any values. We can only access the internal components. Now, a couple reminders. Strings, not an array in Java. They are not iterable at all in the first place, and they don't use square brackets. I don't care what other languages do. We're in Java right now, so square brackets never happen on anything else. Also, arrayless, they have this king sign. They don't use this king sign at all. They never use that. We have methods. They rock. They're a truly object-oriented structure. And also, arrays have dynamic sizing. They resize as needed. So keep that in mind. Therefore, when we're looking at this, again, you want to make sure when you're using array, we remember that they're hipsters, they have some special access using the square brackets, and we go from there. Thank you and have a great day.